In this video, we're going to learn how to solve polynomial equations by factoring. Now, I'm going to start off with teaching you a new way to factor, which is called sum and difference of cubes. So if you ever have two perfect cubes being added or subtracted, you can factor it using this formula here. Now, what are cubes? It's like doing 1 times 1 times 1. Be multiplied by the same number 3 times. So 1 cubed would be 1. 2 times 2 times 2 would be 4 times 2, which is 8. 3 times 3 times 3 would be 9 times 3, which is 27. Then you'll get 64 and 125 and so on. So these are what perfect cubes look like. Now, if I wanted to factor 8x cubed plus 1, 8's a perfect cube. 1's a perfect cube, and x is also being raised to the third power. So I could use this technique, sum of cubes. So the way you would do it is first you would just take the cube root of both numbers. So the cube root of 8 would be 2. Cube root of x would be x cubed would be x. And the cube root of 1 would be 1. You would keep that plus sign the same. Now, for the other factor, you're going to use those two numbers we just found, 2x and 1. And first you'll square the first number, so a squared, so 2x squared would be 4x squared. And then you'll subtract the opposite sign of what you just did here, the two terms multiplied together, so 2x times 1 is 2x. And then you'll always add the second term squared, so 1 squared is 1. So if I did it with the next one, 27 and 125 are perfect cubes, along with x cubed. So that first factor would be the cube root of 27, which is 3, the cube root of x cubed, which is x, and then keep the same sign in between. The cube root of 125 is 5. But for the other term, again, we'll square the first one. Again, we're only going to be using 3x and 5 for the rest of this. So 3x squared would be 9x squared. But now instead of subtracting, you're going to add. You're going to use the opposite signs. You'll notice here that first change is always opposite of what you start with. And you'll multiply them together. So plus 3x times 5, which is 15x. And then you'll always add the last one, 5 squared, which is 25. So that's how you factor with difference, sum and difference of cubes. Now, in the following examples, you'll see that in practice, but not in every single example, because we're going to find the real or imaginary solutions of each equation by factoring. So let's look at x to the fourth equals 16. Now, you might just be able to take a fourth root of both sides, but you're only going to find 1 or 2 solutions, when in fact there are 4 solutions for this equation. In order to find them, you need to move everything to one side of the equation first. So I'll subtract 16. And x to the fourth and 16 are actually both perfect squares. The square root of x to the fourth is x squared, and the square root of 16 is 4. So you get x squared plus 4 and x squared minus 4, the difference of squares from the previous step. Now, this is the sum of squares on the left, so in order to factor that, it works very similar to the difference of squares, which would be x plus 2 and x minus 2. But since it's sum, we'll get those imaginary roots. We'll have to use complex conjugates to factor this, giving me x plus 2i and x minus 2i. So these are my 4 factors. And I just have to set all 4 of these equal to 0. So x plus 2i equal to 0. X minus 2i equal to 0. X plus 2 equal to 0. And x minus 2 equal to 0. Setting all those equal to 0, we get the solutions negative 2i, positive 2i, negative 2, and positive 2 as my solutions. And you'll see here, x cubed equals 1. Yeah, 1 is a perfect cube, but you're going to find all of the solutions if you move everything to one side and factor. So x cubed minus 1 is equal to 0. So now I'm going to factor this difference of cubes. So the cube root of x cubed is x minus the cube root of 1, which is 1. The other factor is going to be the first term squared, then plus x times 1, x, and then plus again 1 squared, which is 1. And I'll set both of those factors equal to 0. I'll get x minus 1 equal to 0. And I'll get x squared plus x plus 1 equal to 0. So x minus 1 equals 0 gets me 1, which is notably the solution we would have gotten if you just tried to solve straight from here. But the other solutions exist in this factor. So now, if I try to factor this, there's no two numbers that multiply to 1 and add to 1, because it has to be 1 times 1, but that'll add to 2. So I have to solve this either using complete the square or the quadratic formula. And I say let's review the quadratic formula. Which is x is equal to negative b plus or minus the square roots of b squared minus 4ac all over 2a. So in this case, a, b, and c are all 1. So as I plug that into the formula, I get x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. This gives me negative 1 plus or minus the square root of 1 minus 4 all over 2. So x equals negative 1 plus or minus the square root of negative 3 all over 2, which when I simplify that radical gives me negative 1 plus or minus I square roots of 3 all over 2. So my other two solutions would be x is equal to negative 1/2 plus the square root of 3 over 2i, and x is equal to negative 1/2 minus the square root of 3 over 2i. So I got two imaginary solutions that you normally wouldn't have found if you just try to solve from here. Now on the top right, I have x to the 4th minus 3x squared equals 4. So again, I want that to equal 0, and I want a factor to find all of my solutions. So I'll subtract 4. And now I have this quartic trinomial I want to factor, but I know how to factor the quadratic a little bit easier. So I'm actually going to substitute x squared for a. So that'll give me a squared minus 3a minus 4 equals 0. Now I'm looking for two numbers that would multiply to negative 4, but then add to negative 3, which would be a minus 4 and a plus 1. So that informs me that this is how the quartic factors, because if I go back and I plug in x squared for a, I'll have x squared minus 4 times x squared plus 1. And I can now factor both of these as well, the same way I did over here. I have difference of squares, so that'll give me x plus 2 times x minus 2. And then sum of squares, which I use complex conjugates for. The square root of x is x, the square root of 1 is 1, but I'm going to use an I on the constant so I can solve it. So I get x plus I and x minus I. Now, setting all of those factors equal to 0, I'll get the solutions. X is equal to negative 2, 2, negative I, and I. For the last one, in order to solve this, right now it's kind of factored on each side of my equation bar, but I'm going to need to distribute this factor in so that I can find all of the solutions by moving everything to one side. So first I'll distribute in the x, give me x cubed plus 8x is equal to, distributed in the 8x minus 8. Now when I move everything to one side, I'll have x cubed on the left. Subtracting 8x cancels out that factor, and I get x cubed plus 8. So now I'm going to factor this using the sum of cubes, which will give me, first factor, the cube root of x cubed, which is x, plus the cube root of 8, which is 2, times, use the first term squared, minus x times 2, which is 2x, and then plus 2 squared, which is 4. And then I'll set both of those factors equal to 0, and then I'll solve. Now, the left factor solves very easily, x equals negative 2, but the right factor is still a quadratic, and it can't be factored because no two numbers multiply to 4 and add to -2. So since I used the quadratic formula last time, I'm going to use complete the square this time. So I have x squared minus 2x equals -4 by moving the 4 to the right side to start. And then I need to add whatever half of the b term, -2, squared is. So that's -1 squared, give me 1. So I'll add 1 to both sides, leaving me with that perfect squared trinomial on the left, which factors into x minus 1 squared, equals -4 plus 1, which is -3. I'll take the square root of both sides of my equation, giving me the absolute value of x minus 1 equals, this simplified as just I square roots of 3. To finish solving, I will take the plus and minus of the right side, give me x minus 1 is equal to plus or minus I square roots of 3, add 1, and I'll get 1 plus or minus I square roots of 3. So my other two solutions along with -2 will be 1 plus I square roots of 3 and 1 minus I square roots of 3. So it's very important to factor in order to find every solution, imaginary and real. And that is how you solve polynomial equations by factoring.